Alright, hi guys. So today we're going to go ahead and talk about parabolas. This is day 2. We have two different forms. One of the forms is vertex form, and that is where you have y equals a, which is my coefficient that either makes it go up or down, left or right, and stretches it, is equal to parenthesis x minus h quantity squared, where h is the vertex, plus k, which is the other part of the vertex. So step number 1, go ahead and graph that vertex point of hk. At the line x equals h is going to be where your axis of symmetry is. Then you're going to make a table using 3 values, graph your points and mirrors, and connect the dots. So first steps first is we have to identify where my vertex point is. So I see x minus 1, so it's at 1, 1. So my point is right there. There's my vertex point, which means that that is also my axis of symmetry. Which is my flipping point, where all my lines will flip around. Or excuse me, all my points will flip around. Then it tells me to pick 3 values, x values. Now, when I pick these, I want to either pick 3 to the left or 3 to the right. It doesn't matter, it'll get you the same. It'll get you the same y values. And when I say left and right, I mean left and right of my vertex point. So since I have y equals, we're going to go up. So I'm going to pick 3 values to the left, 3 values to the left of my x value, or 3 values to the right of my x value. I like positive numbers. I'm just going to go with 2, 3, and 4. So when I plug in 2, I get 2 minus 1, which is 1. 1 squared is 1. 1 plus 1 is 2. When I plug in 3, I get 3 minus 1 is 2. 2 squared is 4. 4 plus 1 is 5. When I plug in 4, I get 4 minus 1 is 3. 3 squared is 9. 9 plus 1 is 10. There we go. So I have a point at 2, 2, 3, 5, and 4, 10. And then I'm going to go ahead and mirror all of those dots, if it will let me. And then I'm going to connect my lines, connect my dots. Bloop. Hey. Bloop. And there's my parabola. Okay. We're going to go ahead and take a look at the following. Now, my vertex is still going to be at that same point of 1, 1. But if you notice, I now have a negative in front of my parentheses. That's my a value. That's going to make that go downwards. So again, I'm going to still have the same, need to pick an x and y. 3 to the left or 3 to the right, doesn't matter. I'm still going to just go ahead and go 2, 3, and 4. That's just what I want to pick. So when I plug in 2, I get 2 minus 1, which is 1. 1 squared is 1. Times negative 1 is negative 1. Negative 1 plus 1 is 0. 3 minus 1 is 2. 2 squared is 4. Times negative 1 is a negative 4. Oh, negative 4 plus 1 is a negative 3. And then I have 4 minus 1, which is 3. 3 squared is 9. Times negative 1 is negative 9. Plus 1 is a negative 8. So I have my vertex points at 1, 1 again. Why? There we go. Then I have, it's going to be the line I flip across, so I'm going to not have that be so fat. Then I have 2, 0, 3, negative 3, 1, 2, 3, 10, 5, 6, 7, 8. And then I flip all of those points. And I go ahead and connect my dots. So again, since that guy was negative, he got flipped upside down. Alright, my vertex here is -2, -3. So for my x and y values, let's see, I could do -1, 0, and 1. So here's my axis of symmetry. And there's my vertex point. Okay, so let's go ahead and plug in the -1. -1 plus 2 is what? 1 squared is 1, and 1 minus 3 is -2. 0 plus 2 is 2. 2 squared is 4. 4 minus 3 is 1. And 1 plus 2 is 3. 3 squared is 9. 9 minus 3 is 6. So I have -1, -2, 0, 1, and 1, 6. And we're just going to go ahead and connect my dots. Okay, so standard form. Standard form is a general equation of a parabola. We are used to seeing this when we use our quadratic form, our quadratic equation, and factoring. We use this form to factor stuff. Again, talking about the A, it's the same idea here. If it's bigger than 0, it opens up. If it's less than 0, it is going down. The axis of symmetry is still the line y, x equals h, And in order to figure out where that's at, where my x and k are at, we're going to use this guy right there, that little formula. Okay, so we're going to go ahead and change this from standard form, change this from a vertex form to standard form. So I'm going to go ahead and actually square this out. So by having something quantity squared, it means that there's 2 of them being multiplied together. So I have x squared plus 3x plus 3x plus 9. Oops, almost forgot that part. Plus 4. So that gives me y is equal to x squared plus 6x. I don't know why this isn't working. Plus 13. Okay, let's try another one. Man, I almost wonder if my pen might be better today. X times x gives me x squared. Not much better. Minus 3x. Ooh, go back. Minus 3x No idea what my computer is doing right now. Plus 9 plus 2. So I'm just simply foiling. So we get y is equal to x squared minus 6x plus 11. Okay, so we're going to go from standard to vertex, and we are just going to ignore this guy. So since I see it in terms of x's, I have to assume that that means it's equal to y here. And we've talked about this in class. You can't have the same variable twice. You can't have x be equal to x's. You can't have y's be equal to y's. So it has to be y equals stuff with x or x equals stuff with y. And I'm going to go ahead and move this around. I'm going to do it this way because I don't like saying that. So what we have to do is I'm going to take and use that y, the x is equal to negative b over 2a formula from a couple slides ago. Now, in vertex form, remember it goes a being the thing with the squared, b being the thing with the x, c being the constant. So a, b, c. So I have 4 as my b, so I need the opposite of 4. Divided by 2 times the a value, and the a value is whatever's in front of x squared, which is just 1. Oh man. It's all kind of frustrating right now. So I have negative 4 divided by 2, which is negative 2. So that means that my vertex lies someplace on the line x is equal to negative 2. So what I'm going to do now is figure out exactly where on that point. So I'm going to plug in negative 2 for x. So negative 2 squared plus 4 times negative 2 plus 4. So that gives me 4 minus 8 plus 4, which is equal to 0. So the point, my vertex point, is at negative 2, 0. So I'm going to use the formula y is equal to a times x minus h squared plus k. And I'm going to put it in terms of this problem. My a value above we decided was 1. My h value is a negative 2, so I have to write plus. And my k value of my vertex is 0, so I'm not going to write plus 0 because we know anything plus 0 is just itself. Okay. Try this again. In terms of x's, so it has to be y equals. So again, we're going to go ahead and use our negative b over 2a. So I have negative 6 divided by 2 times 1, which is negative 6, divided by 2, which is negative 3. So I have negative 3 squared plus 6 times negative 3 plus 4, which is 9, maybe. Thank you, computer. Minus 18 plus 4. 9 minus 18 is negative 9. Negative 9 plus 4 is negative 5. So my vertex point is at negative 3, negative 5. So again, we're going to go ahead and do our y equals. My a above was 1. times x minus h, but because it's a negative, it'd be negative negative, which turns positive. And then my k just follows with. Okay, go ahead and try this one on your own. Come and check your answers to see what you get. Alright, I hope that's what you got. See you tomorrow.